All right, thank you very much. Thank you for your patience, ladies and gentlemen. We are good to go. Our number is amazing, it's beautiful. And once again, good morning from wherever you are, Uganda, Tanzania, Kenya, Rwanda, Burundi. We are so glad to have you this morning for the webinar. I am sure that we all have been looking forward to this. Personally, I have been looking forward to this. And so it's amazing that we have the opportunity to talk about ion chromatography. And our topic today is quite amazing, unlocking the power of ion chromatography in different industries. And our industries for today are quite wide, but also a bit specific to the applications that we have. But before we delve into that, first we'll have a moment of introduction. So as we get to introduction, first I will call us all to observe a few housekeeping rules. One, we ensure that our mics are on mute all the times. And if you have a question, you can use the chat box or you can raise your hands. I'm pretty sure we all familiar with how to raise hands on Microsoft Teams call. So we can raise our hands. Feel free to use chat box as we'll be talking and presenting. You can drop a question, a concern, a comment. It might not necessarily be a question. You might just want to add your voice onto a point that has been mentioned by somebody. Yeah. So there we have. First things first. My name is Joshua Osuka. You can see my name displayed there. Sorry, I've not included the company, but I work with F&S Scientific. I have over 8 years experience in analytical instrumentation, cutting across ion chromatography, spectroscopy, titration, Carl Fisher, electrochemistry, and so many more. I have a team together with me joining this call. I will give them a chance to introduce themselves, then we quickly move to the topic of the day. But before we do the topic of the day, we'll just run an introduction of F&S, who we are, what we do. I also request you to rename renaming your gadgets or rename yourself to include the company you represent so that we can be able to know our partners, collaborators, customers who are also in the call. Just as we do that, I also want to recognize our partners from KenGen, Kenya Electricity Generating Company. We have also our customers from Uganda. I can see Bwana Stephen Ogaba from Directorate of Government Analytical Laboratories in Uganda. I can see George Wanjiru from Tata Chemicals Magadi. We appreciate you. We recognize your presence. And many more. Patrick Mapesa from KenGen. Please also just remember to include your organization in your name, or you can type it in the chat box so that we can also get a chance to know who is in the call. That said, I welcome my team members, Rebecca and Rachel, who will also introduce themselves.
Okay, great. Good morning, everyone. My name is Rebecca Wanzia. I'm a technical sales representative here at F&S, and it's good to see you also. And I look forward to a wonderful session together. So, yes, all the best.
Just give me a shout if you can hear Rebecca. Is sound okay? Madalisto, it's confirming. I guess so.
Perfect. Okay. Good morning, everyone. And I'd like to once again welcome you to this webinar. Thank you for joining. My name is Rachel Wangoye. I am the sales manager at F&S Scientific, currently overseeing the analytical science, food quality and safety, And I am really looking forward to this webinar because I can't wait to what is in store for us as we share our insights and see how together with Metrohm as a partnership, we'll be able to address all your analytical testing challenges. So once again, karibu sana. Over to you, Joshua.
Thank you so much. We also have a gentleman here called Sam. He's the guy behind the deck. The ICT guys don't like to show their faces, but he's also here. We recognize and appreciate his help in this call. Our CEO is also joining us at some point, Mr. Rushabh Shah. So once he's here, he'll have a chance to introduce himself. So straight we move to a little introduction of F&S, who we are. Let's stop that and then I'll share. Oh, sorry, I did not return on my mic. So there we are. It's a beautiful slide about F&S. So as I said, Mr. Rushabh is also on the call. I'll just give him a chance to say a word and introduce and welcome all of us, our partners, collaborators, customers from different industries. Rushabh, over to you. Hi, Rushabh. Uh-huh. Oh, your mic is disabled. Mm. We're just checking if Rushabh's mic is all good. Otherwise, we can proceed. Please check, confirm that you can see my slide.
Joshua, my mic has been enabled. Can I quickly say hello?
Oh yeah, please proceed.
Okay. Yeah, thanks, Joshua, and good morning to everyone who has attended, and yeah, to Joshua and the team, well done for putting this together. So mine is just to say hello. My name is Rishabh, currently CEO of F&S Scientific. Very passionate about the field of analytical chemistry, especially this baby called ion chromatography, amongst all the other technologies that Metrohm offer. And I think the big message, and maybe what I'd like to pose to everyone who's present here, I'm not sure which industries you come from, but I think we must appreciate that different techniques are there and exist and are being applied in different parts of the world to make the impact that they do. You know, they help solve challenges for the products that you're dealing with, for the processes that you're dealing with. For example, with water, if we're talking of water quality monitoring and even safety, but also think of efficiency, etc. And you know, unfortunately, I think in Kenya, East Africa, and maybe parts of Africa, we haven't yet embraced some of these technologies because of the challenges we face in our markets. But the important thing I would like to mention, and something that I really appreciate, is that when we get to interact with many of our customers and the people out there, the beautiful thing is that all of you have a very good and strong understanding and expertise of analytical chemistry. So what's the point there is that the capabilities exist. People know what they're doing. They have a very good understanding of what they're doing. It's just that unfortunately, sometimes they don't have access to the tools and technologies to help them do what they do to the best of their abilities. So I hope that the purpose of today's talk and webinar is really just to discuss, enlighten, create more awareness, and educate all of us about the role of ion chromatography and that it can play in each of your respective industries. So I hope you embrace the information. Please feel free to raise and ask all the questions and challenge us so that we can help you better. And wishing you all a good day ahead. So thank you very much, Joshua. Good luck to you and the team. And yeah, look forward to engaging.
Oh, that's well said, Rishabh. Thank you so much. The reminder is quite clear that we have the capabilities. Capabilities exist. Ours is to share the knowledge, educate, and ensure that everybody is on board in terms of the knowledge and equipped with the right technique. And that is what we also want to achieve this day. So first, we proceed to introducing F&S. As I said, F&S is not a new company. We've been in existence for quite some time, over 40 years. I'm sure most of us are not 40 in this call. Personally, I'm not 40, so it's an old guy. And we're glad to be in the market and just share the knowledge and work together with our customers. So what we want to achieve today is to just show that the principles and of IC exist just for routine and advanced analysis, and also to share with you and our customers and our industry players the various applications that could be put into use in various industries. I also want to emphasize and showcase the real world use cases in quality control and compliance, productivity and process optimization. And finally, also just to discuss and come up with practical pathways. How are we going to upgrade, adopt this technology, the knowledge that we're sharing, so that at the end of the day, everybody is aware of the techniques we are talking about. And as we mentioned, chromatography is not a new technique. It has been in existence. I think one of the oldest techniques that has ever been in use. Many people are familiar with high power chromatography, liquid chromatography, thin layer. I think ion chromatography is a technique that's slowly gaining traction in the market, in our market in East Africa, though it has been in existence for a long time. And so today we basically have the introduction, and then we have a session of listening to our speaker, and then Q&A. So as I said, we'll be typing your questions in the chat box, or you can also raise your hand at the end of the presentation and ask a question. And then finally, we'll call ourselves to action. So 40 years of existence and driving technology within the market, and we make tomorrow better than today. And I'm sure everybody has that aim of existence. Always we strive to make our tomorrow better than it is today and yesterday. And we met the unmet, and we tackle the unmet needs in the market. I think the guys from food industry will be very happy with the sustainable development goal number 2 about zero hunger. The guys from water sector, and I know number 6 will be very critical to you, and so many. So these are some of the sustainable development goals, the SDG, that we also strive to achieve within our work. So what do we stand for, and what do we want to achieve? So we make tomorrow better than today. So that is our reason. So there is always a reason to existence, and F&S exists to make tomorrow better than today through making a difference. And what do we do to make that difference? We supply laboratory and field-based testing solutions. Some of the brands that we partner with, I think Metrohm is the reason for our being here today. apart from Metrohm, we have other brands. I think most labs have F&F. You might have come across F&F or Elga, water deionizer, Velp, Novacina, and many others. Caloaba is a common brand in the chemical industry. And the market we serve is wide. East Africa, we also extend beyond East Africa with our headquarters in Nairobi and an office in Uganda. We are expanding to the rest of Africa, East Africa, and ex-Africa. So soon we'll be able to cover as many territories as possible. And our customer base is also huge, spanning across different industries. We have research, we have the quality testing, regulatory, natural resources, mining, agriculture. And I believe this morning almost every sector is represented here. This is just a basket of what we offer, some of the products that we have, and we also invite you to check our website, check our catalog, check out for something that will be suitable for your lab. So why would you choose F&S? And this is a question that we will also ask ourselves at the end of our presentation. So we might just keep this slide to come at the tail end, so that as we answer the question why Metrohm, why ion chromatography, we are also able to ask ourselves and answer the question why choose F&S. I think so many guys have interacted with our sales team, technical team, so we already have the answer. But for now, let's proceed to have a discussion of ion chromatography, so that at the end of it, we'll be able to ask and answer the question why. So I'll make it, I'll put a comma there as we head to the main presentation. And before we have the main presentation, I just want to invite our partners from Metrohm. Metrohm East Africa is currently supported by Metrohm Central Africa. Our regional office is in Central Africa in Ghana. And so we have the team on the call. Madalitso, I would invite you to just greet us, introduce your team, and then we move to Ahmed. Madalitso, if you can hear me. Sam, will you check if he's enabled?
Good morning. I think I am now. Good morning. Thank you. Like Joshua has mentioned, my name is Madaliso. I'm coming from Metrohm Central Africa, which is currently supporting F&S in all technical sales and every related support in the Metrohm business. So we are glad to meet our clients, and we're very happy to be part of this initiative. So with me on the call, I'll quickly introduce, we have Cecil Ayebo, who is our service regional team lead, who will also, with the F&S team, support every technical and after-sale service that you might request regarding our Metrohm equipment. We have Joseph, who is also our service engineer. And then we have Sigismond and Perfect, who are part of our sales team. So we have basically the whole team in this call to support and to make sure we understand our client needs, to make sure we also have an interaction with our clients. And then lastly, we have our presenter for today, our application specialist, Ahmed Lukman, who will give a brief introduction about himself, and he will take us through the IC presentation today. So thank you so much, and without taking much of your time, thank you, Joshua. Look forward to more interaction. Thank you.
Thank you so much, Madali. So over to you, Ahmed.
Hello, everyone. Good morning. My name is Lukman Ahmed, and I'm the applications chemist for Metrohm Central Africa. I have over 12 years experience in chemistry. From working in an environmental testing lab, and also using instruments like the ICP-MS, the GC-MS, and discrete analyzers. So today I'm going to be taking you through some of the ion chromatograph instruments offered by Metrohm and how it can be used across multiple industries to improve efficiency, reduce costs, and deliver reliable results across industries. So I'm going to share my screen now.
Sorry, if your video allows, maybe you could just see you, then you
Oh,
can.
okay.
Yeah, our attendees might be wondering who is speaking.
Oh, sorry about that. I'm a bit camera shy. So, is it okay to share my screen now?
Yeah.
Oh, okay. Okay, so we are going to be looking at how ion chromatography will be used across multiple industries for improving efficiency, reducing costs, and delivering reliable results. So these are the main topics we'll be concentrating on today. We look at the basics, the applications, and the value proposition of using ion chromatography. So let's start with the basics. So ion chromatography is an analytical method to determine ions or polar substances. And the advantage of it is that you can do all this in a single run. Like every other chromatograph instrument, it consists of a stationary phase and a mobile phase. In the case of ion chromatography, the stationary phase is the column and the mobile phase is the eluent, which carries the sample across the column. And we have different techniques for separation in the column, which we'll be looking at shortly. So apart from the mobile phase and the stationary phase, most ion chromatography also have suppression technologies which help reduce the background noise. And the whole point of it is to give you a better sensitivity. And also ion chromatography we have different detection techniques for analyzing your analytes. So we have the conductivity detection, we have the amperometric, and then we have the UV-vis detection. When looking at the concentration range for ion chromatography, you can analyze trace level of analytes as low as nanograms per liter, that's parts per trillion, to as high as grams per liter, that's in the percentage range. So these are the main steps involved in ion chromatography. First, we have the separation, which happens in the column, then the identification, which is based on the retention time of the different analytes. And you can achieve this by running a certified standard and then comparing the retention times of your run to the standard. Then last but not least, you are able to quantify your results by plotting a calibration curve in your software, and then you can be able to determine the concentration of your analytes. So over here, if you look at this periodic table, we can see some are in red and some are in green. So the ones in red are the elements whose cations can be analyzed by ion chromatography, and the ones in greens are the elements whose anions can be analyzed by ion chromatography. If you look at nitrogen, you realize it's somewhere between red and green. That's because you can have nitrogen existing as ammonia, which is a cation, and then as nitrate or nitrite, which is an anion. So, and over here, we have the schematic of an ion chromatograph system. On the left is a non-suppressed system. So this schematic doesn't have the suppression system. And on the right is the schematic of an ion chromatograph with suppression. So I'll just walk you through briefly the flow path in the ion chromatographic system with suppression. So first we have the eluent being pumped through a degasser, and what the degasser does is remove the gas from the eluent and also removes gas bubbles. And then it is pumped by the high pressure pump, which moves it along into the purge valve. In the purge valve, you are able to remove any bubbles which may be trapped along the flow path. And then it is pumped into the filter. So for ion chromatograph, the ideal situation, we want anything entering the system to be very clean. That's why we have an inline filter. So it removes any contaminants from the eluent or any bacteria and algae which might get trapped in the column. Then it moves on to the pulsation absorber. What the pulsation absorber does is it protects the column from damage by pressure fluctuation. The column is quite delicate, and changes in pressure can cause damage to it. So this is there to ensure that it's protected from sudden pressure changes. And then it moves into the injection valve, and it's at this point that the eluent which carries the sample along mixes with the sample itself. Then from then on, it moves into the column. So this is where the magic happens. And this is the heart of the IC, because this is where the separation takes place. From the column, it moves into the suppressor. We actually have two suppression systems. The MSM, that's the Metrohm suppression model, is responsible for reducing the background conductivity by changing the composition of the eluent. So it changes the composition of the eluent to a chemical which has a lower conductivity. Then from there, it moves on to the second suppressor system, which is the MCS, the Metrohm carbon suppressor. So what it does is it moves CO2 from the eluent. We know CO2 in solution also, when it dissolves in solution, it increases the conductivity of the solution. So to further reduce the background noise, we remove CO2. We remove the CO2 with the MCS. Then from that point, it goes into the detection. It goes into the detector for the detection of the analytes. And this is displayed on your software as peaks. So over here, we'll look at a short animation of what happens inside the column. So the white balls we see here are representing the analytes moving the red balls. Sorry, the white balls are representing the eluents which are moving the analytes, which are the red balls. So a good analogy to picture what happens in the column is imagine a family going to a shopping mall, and there's an entry and an exit. So based on their level of interest in the items in the shopping mall, we can determine who is going to come out first. So perhaps you have the father coming out of the shopping mall first, then followed by the children, then maybe followed by the mother. So is this same principle that happens in the column based on the interactivity between the analytes, the ions of interest, and then the functional groups in the column. It will determine the time it takes for it to elute, and then that's what leads to the separation. So the stronger the eluents, the shorter the retention time, because the eluents also influences how fast the analytes flow through the column. There are various separation mechanisms, and the main one used in most ion chromatograph columns is the ion exchange, and it's used for about 90% of all ion chromatography analysis. We also have the ion pair, and then we also have the ion exclusion. And this is usually used for the ion exclusion is usually used for the analysis of weak organic acids like formates, acetate, and formic acid. So we have various detection techniques for ion chromatography. The commonest one that is used is the conductivity detection, and that makes up about 90% of all ion chromatographic detection. We also have amperometric detection, which is very specific, and it has a high level of selectivity. It's used a lot in the sugar producing industry for detecting sugars for sugar analysis. And then we have the UV-vis detection as well. And that one also constitutes about 5% of all ion chromatograph detections. We also have the hyphenated techniques like ICMS and the ICPMS. So the IC can exist as a standalone instrument, or it can be coupled with an MS or an ICPMS. So over here, we see a video of what happens in the detector. This is a conductivity detector. We have the analyze passing through the detector, and based on the number of ions, is converted to the ions is represented by an increase in conductivity. And this is displayed as peaks on the software. So this is a picture of the various detection techniques offered by Metrohm. We have the conductivity detection, the amperometric detection, and then the UV-vis detection. So we have ICs used across a wide variety of branches, from water analysis, environmental monitoring, the power industry, petroleum, food and beverage, forensic analysis. And the applications just keep growing. And in these industries, it's mainly used for anion analysis and cation analysis. Those are the common ones we know. And it also has uses in transition metal analysis like uranium, thorium. You are capable of also using IC for speciation analysis. So for example, if you are to run arsenic on an ICPMS, you wouldn't be able to tell if it is arsenic 2 or arsenic 3. But with ion chromatography, it's possible to run it and determine the oxidation state of the ion. It's also used for the analysis of organic acids and fatty acids, as well as amino acids. Like we mentioned earlier, we look at the branches and then the applications in which it's used. You realize it's used in environmental monitoring for standard anions in pipe water. So municipal water companies is a very important tool to have, because to comply with EPA standards, you will need to check for anions and oxohalides in tap water, and mineral water producing companies also have to comply to these standards as well. And in the food and beverage, in the food and beverage company, it's used for organic acid analysis, and it's also used for anions and cations in beers. So polar bottling companies, you can use it for analyzing phosphoric acids. And like I mentioned earlier about amperometric detection, you can use it for analysis of carbohydrates. In the power industry, it can be used for the analysis of anions in your boiler water, feed water, condensates, as well as the petroleum industry is also used for the analysis of heat stable salts in your scrubber solution, so that you can determine if you are the ions are going to be causing corrosion to your system. This is another way you can apply it. And in the pharmaceutical industry, it is used for checking for impurities in their excipients as well. So where does the IC fits in your lab. So in your lab workflow, you probably start with sample collection. Then the next step you have to go through is you filter your sample or dilute. The good thing about IC is the sample preparation is not as complicated as some other analytic systems like the ICP-MS, where you have to digest on heat blocks. It's usually just filtration and dilution. Then once it's done, you can introduce this into your IC analysis, into your ion chromatography for analysis. Then once you have your results, your quality control person can do the data processing and then use it to make critical decisions or for regulatory reporting. So this is how IC interacts with other lab sections. So an IC has the potential to replace multiple titration systems. So if, for example, hardness that is being done by titration, since you can analyze for calcium and magnesium, you can calculate the hardness of water with an IC system. And in this situation, it would replace your titration system. You can also couple it with ICP-MS for advanced speciation analysis. So like I mentioned earlier about determine the oxidation state of an element. For example, do we know if it's chromium 3 or chromium 5? It's possible to determine this when we couple the IC with an ICP-MS. So in your lab, it would serve as a complement to your other systems that you use for metal analysis and organic analysis, because it would be the main system you'd be using for analysis of your anions and then your cations. The current methods that are being used, that are commonly used for ion analysis are calorimetry. And this might be in the form of a test kit or a spectrophotometer, or if you are more advanced, you'll probably be using a discrete analyzer. Another way you can detect ions is also with an ion selective electrode. This is also another common way, and titration as well, which we mentioned earlier. But the thing with these methods is they are not that simple. With calorimetry, for example, consider the number of different chemicals you have to buy just for a single parameter. And if you are doing multiple parameters, the cost tends to add up. And there's also the issue of whether you're always going to get supply of those chemicals. And with ion selective electrodes, you usually have one electrode being dedicated to one ion. That means if you plan on analyzing 5 ions, are you going to buy 5 ion selective electrodes? The same with titration. Titration, you also have to buy multiple chemicals for just a single titration. And so the advantage IC has is that you can analyze all these ions in just one single run. And another point I didn't mention in relation to these techniques is that the matrices are usually complex. For example, with ion chromatography, if with calorimetry, if you have interferent ions which also react to give you the endpoint color you are expecting, it's going to give you a false high result. And in ion selective electrodes, to using it, you might have the situation where there are other ions that as the electrode is sensitive to, and this also leads to false results. The advantage with using the IC over this method is able to analyze complex matrices by separating the ions into its into its individual components, so you don't have to worry about interference of other ions. And also another advantage is that the ability to achieve low detection limits. Most of these other techniques are not able to, you won't be able to get low detection limits like parts per billion or parts per trillion. The current emerging applications for ion chromatography is in the pharmaceutical industry. They use it for checking for the purity of their excipients and also to check degradation of their products. Then in the environmental space too, we know there are always new emerging organic pollutants. And currently, PFAS is a hot topic that's been discussed now. And the advantage of IC is that you can use it for the analysis of PFAS, haloacetic acids, and bromates in drinking water. And now that the world is moving towards more green energy, there's a lot of research going on in the battery manufacturing and energy space. So IC is also employed there for trace anions and cations in solvents. And also in forensic labs, is used to analyze for post-residue analysis. So it can be used for gunshot residue analysis. One common technique for analysis in forensic labs is they can take a swab of a suspect who is suspected to have shot a gunfire. You can take a swab, dissolve it in an aqueous solution, and then run it in an IC. And then based on the ions which corresponds to gunshot residue, you can determine if the person is actually guilty or not. So the emerging technical trends in relation to ICs, ICMS that we mentioned earlier, and ICMS-MS. So this combination makes it very powerful for detection of pollutants in the environment. There's also combustion IC for solids. It's been around for some time, but people are beginning to use it more for analysis of ions in solids. So with combustion IC, you heat up the solid substance, it releases the ions, you trap it in a solution, and then you can run it in the IC. The thing about ion chromatography is once you can get the ions into solution, then you can run it. Then we have automated inline sample preparations. And this is a wide range of techniques used to make sample preparation easy when using the IC. We have different techniques like inline ultrafiltration, inline dilution, inline dialysis. And currently there's a new columns that are being made, which are the monolithic columns. These columns are to help reduce the run times for each ion chromatography analysis. One of the pain points of IC is that sometimes people want shorter run times, and it's not always possible if you want to analyze a wide range of ions. So with monolithic columns, it's able to analyze multiple analyze in a short time. And also there's the possibility for online process monitoring. You can put an IC in your in the middle of your process. You can embed it as part of your process, so you can make quick decisions in the quality control. So IC systems are very scalable, and for as a medium lab, you might want to you can start with an entry-level instrument like the Echo IC, and then an auto sampler. It's usually recommended to use an auto sampler for ion chromatographic analysis because it helps with injecting the right volume of the analyte. So you can start with a simple system like an Echo IC and then an auto sampler. But if you have a vision of scaling to a bigger models to higher level of analysis, then you'd want to go for something like the 930 IC or the 940 IC that is shown on my right. So to make scalability easy, we have the 941 production model, Eluent production model, and the 948 continuous IC model. And what these do is they produce your Eluent for you. And it makes it easy for you to run multiple analysis unattended. If you are able to combine the Eluent production model with your auto sampling, and then you have a water purification system that keeps feeding the Eluent production model. The Eluent production model will keep producing Eluent for you and running your samples. So with this setup, you can continue running analysis for up to 30 days without interruption. And yeah, and we also have other technologies to make scalability more convenient. So in the flow part of IC, we looked at sample collection. We looked at sample collection and then sample preparation. Then we looked at the IC analysis. But with the emerging technologies like the Metrohm inline sample preparation, we can eliminate sample preparation from the list. And with the Metrohm inline sample preparation, we are able to integrate sample preparation directly onto the IC system. So let's look at some common Metrohm inline sample preparation, which makes sample preparation a breeze for analysis. So we have the Metrohm inline filtration. And what, like I mentioned earlier about ion chromatographic systems, in an ideal situation, we want to have samples which are very clean, no impurities, no bacteria, no algae that might end up blocking the column. But that's not possible. So what we do is we filter our samples before we introduce them. And that also takes time. So to solve this situation, we have the Metrohm inline filtration, which you can integrate into your IC analysis. And it's, as you can see in the diagram, it filters out all particles and only allows the analyze to pass through. And we also have the Metrohm inline dialysis. What this does is it's meant for more complex matrices. So it uses dialysis to separate the matrix from the analytes. So for labs which probably produce fruit juice, like companies that produce fruit juice, the inline filtration might not work for you, but with the Metrohm inline dialysis, you'll be able to separate the colloids in the fruit juice, leaving only the analytes for analysis. Or if you want to analyze maybe lactose and galactose in milk, you can be able to use the Metrohm inline dialysis to make analysis more efficient. So you look at the value proposition of IC. So let's look at one or two scenarios where IC will be able to solve your situation in a lab. Let's take an environmental testing lab. Assuming you're an environmental testing lab and you just want a contract with a mining company. You've promised your clients you are going to give them a 7-day turnaround time, and they are bringing you 800 samples a month. Now, you first have to ask yourself, what ion analysis techniques are you using? If you are using calorimetry, you are not going to be able to meet your target. If you are using titration or ion selective electrodes, it's not going to be possible because you are going to end up spending 15 minutes just for one analyte analysis. And the second part to look at is the cost involved in a single analysis, you are spending most of your revenue buying chemicals. Whilst with ion chromatography, you only have to worry about the chemicals you use for element production, which is not too difficult to find. For anion analysis, it's mainly sodium carbonate and sodium bicarbonate. So to be able to meet the target of your client, being able to analyze 800 samples in a single month, an IC is going to be your best bet to meet this target for the client, because you are able to analyze multiple ions in a single run. So for anions, let's say you'll be able to analyze your fluoride, your chloride, phosphate, nitrate, sulfate, bromide, all this in a single run. While compared to calorimetry or test kits, is going to take forever to finish doing all this analysis, and the accuracy isn't something you can rely on. So you look at the value proposition and return on investments when using an IC. So like I mentioned earlier with the other analytic techniques for ion analysis, you have to buy multiple reagents. You have to filter your samples, and each analysis requires a separate method. And you also have to invest more time. So you have your human resources being invested in doing one analysis when you can have one person do the whole thing. And the cost per analysis is very high. So when we compare the cost of analysis for ions using either titration, calorimetry, or other possible ways, you realize that the cost is about 3 to 5 times what it costs to run it on an IC. So all these reagents, filters, dilutions that you have to do, all can be done by a single IC system. So if you look on my right, we have an IC system with an auto sampler and then a filtration system. So with this setup, you can combine all this analysis into one. So all you have to do is just inject it for one run. You are able to analyze multiple ions in just a single run. Your workflow is automated, meaning you can free people to do other stuff, and the results is faster and it's more consistent. And one other important factor in relation to IC is it is recognized by most accreditation bodies, and it complies with all the standards. So we have ASTM, US EPA, Occupational Safety and Health Administration, the US Pharmacopoeia. So all this, so if you are a regulatory body or you need to maintain some standards, you need to keep up with these standards in audits, you have to consider going for an IC. And that would make your audit process quite simple and more convenient. So if you look at it, you realize that the IC is not just an instrument, but it's something that is a technical solution, but a valuable investment for modern laboratories to make their workflow more efficient and much easier. So the key takeaways from ion analysis with ion chromatography is, one, you are able to run all your ions in a single run. It's a multi-ion analysis system, and there is the possibility for automation to make handling a large number of samples more convenient and easier, and to increase your return on investments. So At this point, if there are any questions.
Thank you so much, Mr. Lukman, for the great presentation and just taking us through that session of knowledge sharing. It's been amazing, and I just invite our attendees just to give a thumbs up if you like the presentation, if you learned something. As Rachel had mentioned, feel free to share your questions in the chat box. You can also raise your hand, and we'll be glad to limit this to about, I think, 2 or 3 questions per person. And I also have questions for our participants today. So if you score all my questions, we'll send you your gift, even if it is in Tanzania or Uganda. So yeah, as Ahmed has mentioned, I have picked 3 key things. We are saving on money, time, and accuracy. That was a resounding call to efficiency throughout the presentation. So thank you so much, Mr. Lukman. We open this to question is Q&A, as we would call it. So let's start with Rachel, who is appearing first on the chat box. Yeah, the first question from the chat box was Eric. I think Eric is from, is it Total Energies or from Kenya Fishery? And his question is, what are the achievable limit of detections and limit of quantification for common anions and cations? I think we can take another one, and then our speaker will just respond to them. Peter Kimeu, government chemist, please, you can ask the question. Eric is from Kisumu Water. Thank you so much. That is Kisumu Kiwasco. Yes, Peter, please proceed. Oh, or your mic is.
Just minutes here.
Oh yeah, I think we just trying to check how to enable your mic. Please, Peter Kimeu.
Yeah, can proceed.
Yeah, you can proceed, Peter. I think your mic is enabled.
Yes, sir.
Peter, we can't hear you. Just try again. You're on mute. Okay. As Peter tries, we can also take a question from somebody else. Benedict Kenjen should be.
Good morning, everyone. Yes. Hope I can be heard from the other end.
Yes.
Yeah, that was a very nice presentation on IC. I have a question, and this question goes to the type of water. IC being one of the most sensitive equipment for the analysis, sometimes we find a lot of blockages in the pipelines. What is the current? What does the current developers think about making IC to be also just like any other equipment where it can actually handle some coarse water? Just like if you compare IC with the AAS, AAS is a bit robust, it's a bit coarse. It can be able to handle some coarse liquids, especially, for example, the reason why I'm asking about this is because I deal a lot with geothermal water, and getting geothermal water to be as clean as possible for IC analysis sometimes is very challenging. So I don't know what the developers would be thinking about these coarse water samples that may not necessarily be as pure as water or distilled water. So when you're carrying out the analysis, you experience a lot of blockages, and that would mean more cost in terms of maintenance. But personally, my experience with the IC has been so nice. When you're doing steam analysis, you get very nice results, very good results. The only challenge is that most of the ICs come as a double components or single components. For example, if you want to analyze the anions, you have to use the anionic column when you want to analyze. So you keep changing the stuff. So I don't know, is there anything that, again, the developers are thinking about having just a suitable general column? Because now with the advancement of the technology, I think that is the way to go. Much as the current systems are working properly, I would also start thinking about having just a single system that will be able to handle both the cations and anions. And by so doing, it's going to actually assist and reduce the time for analysis. Otherwise, it was a very nice presentation. I am Benedict from Kengen. Thank you so much.
Thank you so much, Benedict. I know we worked together with you on your IC, and my hope is that one day you'll get another IC so that you have an uncut IC that is able to do anions and cations. Currently, you only have one, which has been a limiting factor. But over to Ahmed, I think you can respond to the, are there two or three questions? One from Eric
Yeah, so
and Benedict.
this was from Eric, right?
Yes.
Yeah, so Eric, to answer your question, you know, technology is trying to catch up with all these things you've mentioned. We are trying to develop, it would be ideal to have a technology that would make it the column so simple that it can handle any kind of water. But we've not gotten there yet. That's why we still have the inline ultrafiltration and inline dialysis. So before I continue, I would like to ask, do you have any of these integrated into your IC systems?
Okay, on behalf of Benedict from Kengen, their system does not have any MISP, MISP technique, so everything is done outside.
Oh, okay. Okay, so the filtration is done outside. So maybe we have to start looking at the pore size of the filter paper being used, because in the IC ultrafiltration system, the pore size is 0.2 microns, which is a very small pore size, and it makes sure even bacteria aren't able to enter the column. So maybe that's where we can start by changing the filter paper, or you can implement the inline ultrafiltration or the inline dialysis. But for now, we don't have any new columns which are able to handle that kind of water. But research is still ongoing in those areas.
Okay, thank you so much. There was a question from Eric. I don't know whether you responded to it about the LOD and LOQ.
Oh, okay. So for ion IC systems, you can, the LOD is as low as nanograms per liter, that's parts per trillion. And usually LOQ is roughly 5 times the LOD. So it's still within the same range. So we are looking at PPT values. That's 1 in trillion, 1 milligram in a trillion per 1,000 kilograms.
All right, thank you so much for that. There's a question from Boniface Mutuku from that should be Total Energies, and Patrick Mapesa from Kengen. So Boniface is asking common mobile faces for IC in the petroleum industry. And then Patrick is asking what causes high pressure pump to register high pressures. That is one question. Question two, still from Mapesa, is what causes Metrohm suppressor module system leakages and quick remedy to it.
Okay, so let me respond to the high pressure pump issue. So high pressure pump, what might cause it to register a high pressure is maybe you suddenly decide to change the element, so you remove the tubings and then you switch out and put in another element. That will cause a high pressure to register in your chromatograph system. Also, if there's a bubble trapped in the flow path, it's going to cause it to register as a high pressure. Those are the two main ones that comes to mind immediately. And when you say what MS system leakages, I don't quite understand what you mean.
Let me check.
Is it physical leaks or?
Let me check if yeah, but I think Mapesa is still on the call. Can just unmute you and then you clarify on the question. Yeah, Mapesa, please try if you can unmute and speak.
Okay. Am I clear?
Yes,
You are clear.
Okay. My what I meant is when you are doing the analysis, you are running the analysis, you find that some of the eluent is leaking just down the MS module, the system. So that leakage is leaking like some of the liquid coming out of the MSM system. So the question is, what could be the cause of those leakages and what could be the quick remedies to it so that you can continue the analysis? That is the question that I was trying to ask. Then the third one, maybe I wanted to come back and so that I can finish all of them, is that the third question is, when you are running for CRMs, and this CRMs has, for example, 4 analytes, and then when the equipment is taking them, it only gives you the peak of 3 analytes, and then another one is omitted. So that is during the quality assurance and quality control processing. So what could be the cause that equipment omits 1 analyte that is in the CRM and then register the 3? Thank you.
Okay. Okay, for the leakages in the system, I'm thinking the connections with leakages, it usually has to do with the connections. You have to tighten your connections. I don't know if the connections have also been over tightened, it's possible to cause a leakage. And you might want to consider changing the connections, getting replacement parts for those connections if it still persists after tightening it. And to your question about some of the analyze not registering, even though you have a 4-component CRM and it's only showing 3, it could be the first. What comes into mind immediately is that is probably the program you are using, the method you are using. Maybe it's not the ideal method for the analytes that you are running. And secondly, could be also maybe the element you are using. If you are using an element which isn't ideal for that system, for that group of analytes, it could also lead to you not seeing the peaks. Is it that the peaks doesn't show up at all, or because sometimes you have the situation where you have the peaks showing, but it's so small you can't see it unless you zoom in, because compared to the neighboring peaks, those ones are so big they dwarf it.
Yeah. I think I just to add on that. The third possibility could be your CRM or the QC check has 4 analytes, and your calibration curve did not include that particular analyte. So it's not either it is not assigned, the peak is not assigned an analyte, or the analyte it does not exist in the calibration model. Hence, it's not been able to be named and assigned. So yeah, that could be possibility. And on the question on the leakage, I noticed that the rotor for that IC was a little misaligned and faulty, I think, because of the drying up of the certain salt. So that when the rotor tries to move during the suppression, that's stepping. So what happens is there is some resistance, and that resistance causes the leakage. And that this is something that needs just to be checked and the rotor refixed. Okay, that is it from on that question. I'm just trying to check the chat box.
Okay.
And the Metrohm
Mhm.
being installed in the Eco IC. Was that the answer?
Okay, I think there's the other question is there a need of filtering sample before injection, and you can see with your eyes it is clean. Oh yeah. If you can use your eyes to judge the suitability of samples or injection, then there is a question on can the Metrohm online filtration component be installed in the Eco IC, and that is the inline filtration system. And then probably what is the limit of detection and limit of quantification for key? I think this has been handled. Yeah, question from Alexander. Ahmed, do you want to take this too about sample filtration and sample online inline filtration unit on Eco IC?
Yes. As far as I know, the Metrohm Eco IC, you can integrate the inline ultrafiltration on it. Yeah, so it's possible. Maybe it's time for an upgrade. You can upgrade it to include the inline filtration.
On Eco IC, right?
Yes.
Yeah, but you'll have to get the right auto sampler.
Yes, you have to use it with an auto sampler.
Yeah, because if this is pulling from Nairobi Water, so that should be the 863 auto sampler currently in use.
Okay.
So yeah, we may just need to upgrade the auto sampler.
So they are okay. So currently it's not been done with an auto sampler.
No, it's done with 863.
Oh, okay.
Mm-hmm.
Is it a question or
is there any other question?
it's a email?
So the other question.
Peter had a question on the price, which I responded to on the chat box.
Okay, there's one question here about common mobile faces for IC in the petroleum industry. So for IC in the petroleum industry, I'm sure probably for heat stable salts, which are mainly anions and some organic acids, you can use a sodium carbonate, sodium hydrocarbonate in an aqueous medium as the eluent for the anion analysis. And for cation, you can use nitric acid and diprocholic acid in an aqueous medium for the eluent in cation analysis. So
Okay.
that question was from Boniface.
Yeah. Okay. Thank you so much. There's another question from Eric. Eric from Kiwasco. Kiwasco is Kisumu water. What is the typical percentage relative standard deviation for repeat analysis at low concentration? It's a bit technical. That one is an joke question.
This I'll have to consult the notes, but I know it's very low. It's very low. I don't want to put a number out there, but as we know, ion chromatography is the gold standard for ion analysis. So it doesn't get better than ion chromatography. If you can't get a low repeatable value on IC, you can't get it anywhere else.
Oh, perfect. Perfect. Thank you so much for that. Yeah, we'll be able to respond to that. We'll get in touch with Eric on that question once we have a firmed up answer in terms of the RST. Okay, so I said I also have my question, and the winner will get a present. So question one, you can just type your answers, your answer. So this is to everybody as oh, so there's a question on the type of detectors. I think that was covered, but we can also we can reach out to Mungai and share that presentation or share the type of detectors, basically the conductivity detectors, amperometric detectors, and UV detectors. And we'll just give you a summary of how they compare. So my first question is this to the participants. How low in terms of detection limits can IC go? So if the first one to type an answer will get F&S Zawadi, F&S present. How low can IC go in terms of detection limits? Correct. And this should not be answered by John Kamau, you are still. That question is disqualified because it was first answered by a member of F&S. So the second question now, which type of detection technique is used in the sugar industry, or which type of detector is suitable for sugar analysis output? Out of the three detectors I've mentioned, conductivity, amperometric, and UVVs. So which type of detector is most suitable for sugar industry, sugar analysis? So, and the winner is, for that question, Eric from Kisumu. That should be Eric from Kisumu Water. Second question, any MISP technique mentioned by the speaker? MISP is MISP, Metrohm inline sample preparation technique. Any sample preparation technique that was mentioned by the speaker that you remember? Again, the first person to answer that gets a reward. So the first question was, Pauline from Nairobi Water should be. And yeah, somebody has just made it good. Now inline filtration, and then there was filtration from Pauline. Pauline, you missed the inline.
No present.
That question, and then that is the last one. Which regulation mentioned by the speaker does the water industry need to comply with? which one regulation mentioned by the speaker does the water industry need to comply with? Water, remember this is water industry. And it was mentioned by the speaker. We have not yet got a winner. Can still try. And there are some also in the chat box. Now we are still waiting for the correct answer.
International.
This must be this is an international regulation or standard. It was mentioned by the speaker, I think, in the very first part of the presentation. Okay, we are giving you a hint. It starts with an E. We've not got a winner, so there's no reward for that. And our answer is EPA. So we didn't get a winner for that question. So we have two winners today, Eric and
Peter, and Mungai.
Okay. Thank you so much. We just go back to the summary part, and Rachel just mentioned something about the. I'm just opening it. Why F&S as we conclude?
Okay. First of all, I'd like to thank the presenters, that's Lukman and Joshua. I think you did an amazing job. So good job on that. And I think all of us have learned something new. We all got some valuable insights on how well the ion chromatography can be able to, change our lab processes and operations. So now, as Joshua was saying, as we recap, and I know there's so many suppliers out there, either supplying ion chromatography or any other brand, but we just like to emphasize why F&S Scientific based on this. So we have the solutions, as Joshua mentioned during the introduction, the fact that we've partnered with quite reputable brands in the market, i.e. Metrohm being one of the brands that we work with. I think it's been almost a 10 years journey. So not just that we've just onboarded them the other day, we've had the experience, we've interacted with the equipment, we've gotten good feedback even from the market, and any other brands that have been mentioned here. And then apart from that, I think we have been backed up by support, because it's one thing buying an equipment, but if you're not getting the right support for it, then it becomes quite invaluable, right? So in terms of training, we have quite a big technical department comprising of engineers and application specialists on the same. So we offer training and installation. And then in terms of the after-sales support, we do maintenance for your equipment, both preventive maintenance, and now depending again on the type of equipment that you purchase, it can be periodic or annual, or up to 6 months, depending on the equipment. So the support is there in terms of even method validation. If, for example, you bought an IC chromatograph, we need to do the method validation. We need to optimize the methods. That can be handled by our application specialists on the same. And then additionally, all our equipment are on warranty, and that is very, very important. Of course, our warranty covers specific items on the same. And I know we get into trouble with most of our customers when we're not quite clear on what the warranty covers. But just to be on the safer side, and I think Lukman mentioned about what differentiates our IC from the other ICs in the market. We have our, suppressors dating back to almost 10 years, right, on warranty. And then now we have the main equipment warranty that is close to 3 years, 2 years, and 1 year, again, depending whether you have a contract, an annual maintenance contract with us. And then lastly, in terms of capacity building, we organize workshops throughout the whole year. We have mini workshops where we call them the training academies. So where we invite just a few customers just on board, prospective customers and existing customers, just share and network and be able to share this information. In terms of now sustainability, I think we can say that confidently, yes, you can be assured of quality when you buy our equipment, the practicality when it comes to the using of equipment, and cost. Yes, and I know when we talk about these CapEx equipment, yes, they can be expensive, but and I think one of the things that we try even talk to our customers is try give that guideline on how we can be able to calculate the cost of ownership, or then be able to very clearly demonstrate the return on investment. So Joshua, proceed to the next slide kindly. So with that, ladies and gentlemen, I'd like just to conclude this webinar by just highlighting some of the next steps in terms of the call to action. So yes, it was very insightful. We learned a lot of things. And in case you'd like some bit of personalized consultation, we are here with Joshua, Rebecca, and the bigger F&S team on the same. So we can speak to you after this meeting. We have all your details. We'll send an email and the PDF for the presentation and some of the application notes, again, depending on your application or industry. Kindly share, if you don't mind, for those who are interested in this equipment, you can share your current testing challenges, and then we can recommend a solution for you. We'll walk you through this journey. And then you can also request an application guideline for your specific samples and workflow. And then the next step would be, obviously, I'll just like to happily announce that we've just gotten our demo unit.
Oh, yeah.
So we have the 930. So in case you want to see the equipment in action, that can be organized. We already have some customers who've confirmed. I think we have about 10 customers. So what we'll do, we will schedule them, that we have a very small group and you can have that personalized feel about the equipment. Yes, and I know our salespeople like talking, but it's good, especially for the end user and the lab analyst, to just come with your samples and you can be able to run the samples in our demo lab. And then next, I cannot forget, and I want to thank our existing customers who've been quite patient with us. And I know there are challenges, especially with this a bit not so complex equipment. But yes, we will offer refresher training for your team and the new users. Again, we continue offering we will continue to offer the ongoing technical support and method development assistance. This is to Nairobi Water, this is to Kengen. So please feel free to get in touch with Joshua, who's an application specialist, and we will continue offering you the support that you require. And then lastly, I hope you all partner with us as we try to modernize your lab and make your operations quite efficient. And I look forward to this journey and future business partnership. So thank you so much, and like to give this back to Joshua to conclude.
Yeah, thank you, Rachel, for that call to action and just reminding our listeners and viewers for that reason that we are here to support. We have the right technology, we have the right knowledge. And also thank you, our presenter, Lukman, Madaliso, Rebecca, and F&S team Metrohm, and our participants for the day. We are happy that you joined this call and we're able to partake it together, learn. Now the knowledge is there, have the right information. Please go ahead to make your inquiries. We'll be glad to host you in our demo office. Our 930 IC is already here. And with that, we bring it to a beautiful end.
I would like to thank. I just wanted to thank Joshua and Rachel for putting together this webinar. It's very well organized, and I really appreciate the chance to speak on your platform.
Yeah.
Thank you, Lukman.
Thank you, Lukman. So please feel free to reach out to us through the email address or phone number. You can continue with the questions. You can continue What you need to type in the chat box, you can directly write to me on my phone number, WhatsApp, and the email address shown here. All right. Have a wonderful afternoon and bye-bye.